Morning, guys. I have pre-recorded another sections for you. We will do today two sections, section 3.3 and 3.4, but I will split it to two clips. And if they let me board the plane on Friday, then I will be back next week. And then we will just continue with the normal lessons, normal online lessons before I can go back to school. So we'll start with section 3.3. That is about multiplying and dividing complex numbers. You know already how to do them, these operations, but you should be aware of what effect, what impact it has on the modulus and on the argument of the complex numbers. So if you have two complex numbers given, let's say z1 and z2, let's say this would be x plus yi and z2 would be a plus bi, doesn't matter, but there would be modulus r1 and argument theta 1, and this one would have modulus r2 and theta 2 would be the argument of the z2. So important part that you need to be aware of, if I do multiply complex numbers, if I multiply two complex numbers, then this is true for their modulus. Modulus z1 times z2, the product, the modulus of the product is equals to the product of the moduli. z1 times z2, or you can say r1 times r2. And then argument of z1 times z2 is equals to argument of z1 plus argument of z2. Or you can say theta 1 plus theta 2. Okay. The second one is for the division. What is a similar story? If I divide two complex numbers, then the modulus of the quotient, the modulus of the division, is the ratio of the moduli, z1 divided by z2, or you can say r1 over r2. And for the argument, similar story. If you have z1 over z2, then it's the argument z1 minus argument of z2, or you can say theta 1 minus theta 2. Okay, so you need to be aware of this, you need to be able to use it. So this would be for the product, this would be for the division, for the quotient. You can find the proof if you are interested, but you do not need to know it. But for those of you who are interested, page 24 in the book, there is a proof. There is a proof that this is true, that this works. Okay. Again, you do not need to know this one. You will need to know another one from section 3.4. Okay, so let's look at some questions. First, I'll do some question that is not in the book. Let's just try some. For example, I'm going to call it example 1. Okay, imagine you have z1 would be 1 plus I, and z2 would be, let's say, root of 3, root of 3, 1. So 1 plus root of 3i, 1 plus root of 3i. So when you imagine these, when you imagine these complex numbers, so z1 is 1, 1, this would be the z1. Okay, and then you have 1 plus root of 3, this would be the z2. And if I multiply this, we can try z1 times z2 equals 1 plus I times 1 plus root of 3i. And if I multiply, they'll get 1 plus I plus root of 3I plus root of 3I squared. What would be 1 minus root of 3 plus I 1 plus root of 3. Okay, this is roughly minus 0.73 and this is roughly 2.73, roughly. Okay, so because I just want to sketch it, so it would be somewhere here minus, and 2.73 it would be somewhere here. Okay, so this would represent the product Z1 times Z2. Okay, I'm going to call it Z3 or Z, just Z. I'm gonna call it Z. Okay, now what I want to show you that the formulas that we introduced at the beginning do really work. When you look at the Z1, R1 would be the modulus of Z1. What is root of 1 squared plus 1 squared? What is root of 2? And obviously the argument of Z1 is 45 degrees or pi over 4. Okay, because it's 1, 1, so it must be pi over 4 or 45 degrees. Now for R2, the modulus of Z2 is root of 1 squared plus 3, what is 4, so 2. And argument of Z2 is is arctangent root of 3 over 1. Let me see, arctangent of root of 3 over 1, what is 60 degrees or pi over 6. Pi over 3. Now, if what we said is true, then Z2 modulus, Z modulus is R1 times R2, what is 2 times root of 2, and argument of Z would be 45 degrees plus 60 degrees, or you can say pi over 4 plus pi over 3, what would be 105. So I can say this would be 12, 7 pi over 12. Okay, I am asking if this is true. So because I know what my Z is, this is my Z, this green one, so I can find out modulus of Z is root of 1 minus root of 3 squared plus 1 plus root of 3 squared, what would be root of 1 minus 2 root of 3 plus 1 plus 2 root of 3 plus 3. So these two cancel out. So it would be 3, 6 root of 8, and root of 8 can be written as 2 root of 2. What is exactly the same as this one? That means this one is correct. Okay, so for this one it works. So for the modulus of R1 and R2, it was equals to modulus of Z. Now we're going to verify the argument. So argument, if you look at the picture, I'm going to call it theta, this pink one, and I'm going to find the alpha. So the theta would be the argument of Z, would be pi minus arctangent. But in here you have to be careful because I have done that mistake before as well. Remember, if you are looking, these two must be positive numbers, right? Because they are the sides of the of the triangle. So either put it in the absolute value, but the first one is definitely positive, but the second one is not. Okay, so be careful with that. Oops. So because this is negative 0.73, so if you put it to the absolute value, it would be actually pi minus arctangent of 1 plus root of 3 over root of 3 minus 1, because that's the absolute value of it. Okay, so when you try to do that, you can check with the calculator pi minus arctangent, but you must be in radians, do not forget that. 1 plus root of 3 over 1 minus root of 3, and that is, oops, sorry, root of 3 minus 1 of, I type it wrong, root of 3 minus 1, and when you press equal, then it's 7 pi over 12, what is exactly the same as this one. Okay, that means the rules that we introduce are correct and they do work really, and you can see it. Okay, so when you multiply two complex numbers, the modulus of the product is the product of two moduli, and argument of the product is the sum of the arguments, right? Modulus of the product of Z1 and Z2 is the product of the moduli, of two moduli. Moduli is the plural from the word modulus, and argument of the product of Z1, Z2 is the sum of the arguments, of the original arguments, yeah, or of the arguments of Z1, Z2. Good. So now we can look at some of the examples from the book. Very easy. We need to express the following in this form. Wherever it's possible to simplify, we will simplify this one. So when you look at the A case, it is 1 times cosine 2 theta, blah, 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 1 times cosine 3 theta, blah, blah, blah. So these are the modulus and these moduli, and these are the arguments, right? So what the rule tells me, I can just multiply the modulus and I can add the arguments, 2 theta plus 3 theta plus I sine 2 theta plus 3 theta, what would simplify to 1 times, obviously 1 doesn't need to be written, cosine 5 theta plus I sine 5 theta. So this would be your x and this would be your y. Okay, that can't be simplified any further. But when you look at the B case, that's the similar story. Again, there is 1 and 1 as the modulus. So 1 times cosine, and I just add it directly here, okay? 3 pi plus 8 pi, so would be 11 pi over 11 plus I sine, and again the same story, 11 pi over 11, but obviously you do know that 11 cancel out, so I only have pi. And this can be simplified. Cosine of pi is minus 1, sine of pi is 0, so it would be minus 1. So minus 1 can be written the same way. This number is the same as this number. Okay, let's look at something else. What is important to point out, if you want to apply these rules, these signs must be positive, must be plus in the middle. And in case they are not, you need to modify it. So how to modify it, we learned that, and I showed you that in section 3.1. You have to use the even and odd properties of the function sine and cosine. So sine of negative theta is negative sine theta, and cosine of negative theta is the same as cosine theta, because one is this is odd function and this is even function. All right, you can have a look if you forgot. So before modifying it, before rewriting it, before multiplying it, you need to modify it first, this minus sign in the middle. So I would have this times, and then I need to rewrite it at cosine minus theta plus I sine minus theta. Okay, and now I have plus plus. That means I can take the arguments and add them up, or multiply also the modulus with the second modulus. But that is 1 times cosine. So when I add these, I'll get 3 theta plus I sine 3 theta. Okay, similar story is for h, but in this case, look at the modulus of the first one, modulus of the second one, so it's 3 times root of 2 times, and before simplifying it, you need to write both of them with a plus in the middle, times cosine minus pi over 3 plus I sine minus pi over 3. Okay, so when you look at the plus, that means you can add it up, and then you will have 3 root of 2 cosine. When you add these up, then you will get, let me see what you're gonna get, pi over 12, so 12, 1 minus 4, so minus 3 pi, plus the same I sine minus pi over 4. Okay, and when you simplify it, it's 3 root of 2 times, this is pi over 4 cosine, so cosine is positive in the fourth quadrant, so root of 2 over 2, but sine is negative there, minus root of 2 over 2i. And again, when you simplify this, then it would be 3 minus 3i, if I'm not mistaken. 3 minus 3i, this should be fine. Okay, so this would be the first question, or first kind of exercise. And then the second kind of the problem that you need to be able to do in this section, I think that's this one here. So let's do these two questions. Then there is a division. So similar story, except we will apply the second rule that we learn. Okay. Again, please be careful. There must be plus in the there must be plus here, and in case there is a minus, you need to do the same thing as we have done there. So in here, the arguments are 1. Modulus is 1. So 1 times cosine 5 theta minus 2 theta plus I sine the same story. So it would be cosine 3 theta plus I sine 3 theta. And in here the same, but I need to divide these numbers. So when I divide this, I will get 2 times root of 2. And cosine pi over 2 minus pi over 4. What would be pi over 4? You can just write it straight away, and I'll write it this way. And in this case, I can simplify it. So 2 root of 2 cosine pi over 4 is root of 2 over 2 plus I root of 2 over 2. And when you simplify it, then you will get 2 plus 2i. 2 plus 2i. Okay, and good. So this would be it for this section. I'm going to stop the video now and look at the OneNote later, which exercises you need to practice. Okay.